Hello guys, it's me again. We just covered dehydration, right? So right now we are going to go through the last reaction of alcohol. Okay, so that is oxidation. Oxidation, okay. Now for oxidation, we have already learned the oxidation of primary alcohol in Form 4, right? So primary alcohol means, as I said, the carbon that is next to the oxygen has two hydrogen atoms, right? So 1, 2. I still cannot change the color. So frustrating. Okay. So when it is oxidized, as you know, it will form an aldehyde. And we have another name for it. It is alkene. Now, if you don't isolate this out by distillation, for example, if you are using reflux, then it will continue to further oxidize to carboxylic acid. That's why alcohols, if you put it in oxygen for a period of time, then it becomes sour because it becomes acid, okay? So this is what we have learned in IGCSE. This is primary alcohol, right? Oh, now for secondary alcohol, as I told you, it means the carbon that is bonded with the oxygen has only one hydrogen, and the other one is alkyl group. So in this way, when it is oxidized, it will become a ketone. So it's very easy. You just keep this part and then put a double bond here. Then try to eliminate this part and eliminate this part. Then that's it. Let me give you a concrete example. For example, this one. Okay. When it is oxidized, if you look at this carbon has 3 bonds. 1, 2, 3. So one hydrogen is contracted because it is skeletal formula. So that's why it will become a ketone. Cyclohexanone. What a beautiful name. You can call yourself cyclohexanone if you want to remember this name more. Okay, any question? This is called ketone. Ketone, okay? Well, the third one has nothing to say because, as I said, if the carbon atom that is bonded with the oxygen doesn't have any hydrogen, then it cannot be oxidized. It's resistant to oxidation. Okay? So, give you an example. You need an example. So, just like this one, 1 bond, 2 bond, 3 bond, 4 bond, which means there is no hydrogen. So if you add oxidizing agent, no reaction. Okay? Now normally the oxidizing agent we use is acidified dichromate 6 solution. 6 means this one. The oxidation number is positive 6, okay? And as you know, it will be reduced to chromium 3. So that's why a very obvious color change can be observed from orange to green. Any question? If no question, then let us go back to the NOx. Okay, NOx. Alcohols can be oxidized by, the color changed, then scarred. Okay, so potassium dichromate 6, okay? 6 refers to the oxidation number of chromium, okay? With dilute sulfuric acid, or you can simplify say acidified. potassium dichromate. Okay, the solution orange color, I already told you originally it's orange, but in presence of the dichromate ion. When the dichromate 6 ions react as an, I just told you, you oxidize alcohol, of course you need an oxidizing agent. This N already told you this is a vowel, right? So definitely not reducing agent. They themselves are, when you oxidize someone, agent means you help to oxidize the other one. So you yourself has to be reduced, right? Because redox reaction goes in pair. One undergoes oxidation, the other one undergoes reduction, and turns into chromium 3 ions, Cl3 plus, which form a green solution. The reaction mixture needs to be warmed before the oxidation takes place, of course, okay? Or sometimes if you want to oxidize a primary alcohol all the way to carboxylic acid, you can use heating under reflux. It's up to you, okay? The product formed where alcohol is oxidized can be used to distinguish between primary, secondary, and tertiary. Of course, this is what I just told you, okay? For example, in the exam, if I ask you to distinguish this one and this one, then you can use acidified dichromate solution together with heat. For this one, since it's a tertiary alcohol, it doesn't have any reaction, so the orange solution will remain orange. But this one, since it's a secondary alcohol, it has a H, so it will be oxidized to ketone. At the same time, the dichromate will be reduced to chromium 3, and you will see a very obvious color change towards the breaking news. Don't disturb me. Oh, okay. Anyway, 好嗱 let's just go for it one by one. Oxidation of primary alcohol, which means the carbon has 2 hydrogen together with OH, right? Okay. When primary alcohol is the avenue, the alkyl is oxidized to A. Already told you the intermediate is aldehyde, or you can call it alkene. Now, ethanol is oxidized to ethanol. Okay, now how can we write a balanced chemical equation? As I told you, when we write balanced chemical equation for organic reactions, normally we will not be so detailed. We just use bracket O to represent the number of oxygen atoms. At the same time, it means oxidizing agent as well. So ethanol, right? You know that it will turn to ethanol, right? Ethanol. So what will be happening is you will see 2H here, and there is the 2H is gone, right? So you can guess it goes to water. But if you put a water here, you have 2 oxygen atom on the right hand side, and you only have 1 here. So you add 1 bracket. That is the balanced chemical equation already. Okay. Wow, very beautiful. Continue. The aldehyde can be obtained by, I already told you that if you want to get the aldehyde instead of carboxylic acid all the way, you need to do distillation. Okay. The ethanol formed can then be further oxidized, okay, all the way to form ethanoic acid, which is a carboxylic acid. Carboxylic acid means an organic compound. What's up? That contains COOH group. Keep quiet. This is achieved by refluxing with excess. Of course, if you want it to go all the way to carboxylic acid, you need a lot of oxidizing agent. So when we write chemical equation, oh, 同出出 Thanks God. I don't want to do it all over again. Okay, continue. So aldehyde, then it will be oxidized to carboxylic acid. So when you look at this equation, when you look at this equation, the right and left hand side, the only difference is there is one more oxygen, right? So you add bracket O here. Okay. Oh, let's do some classwork.